BioRevolution Podcast.
Your hosts,
Andreas Horchler
and Louise von Stechow.
Welcome everybody. You may wonder, we usually do audio exclusively. Now we try video as well. Please tell us in the aftermath if you appreciate what we're doing. This time around we said we do something about out of the lab into the code, an age of AI scientists. Spectacular, probably not so much, because at the end of the day it might be only zeros and ones, but maybe it's a little bit beyond that. Easy, welcome. First of all, of course, you always bring quotes.
I do, and I brought quite a few today, so I have to pick which ones I like the best. Maybe starting with one that's very enthusiastic about AI scientists, which is actually from one of the developers, Vivek Natarajan, who's at DeepMind and who was involved in developing Google's co-scientist. So he says the co-scientist is like a smart scientific partner capable of seeing the obvious and non-obvious connections in a sea of research. We hope to give scientists superpowers. So,
oh, wow.
Modest.
Yep.
Yes. And then I have a quote from Tom Hope, who's a computer scientist at the Allen Institute of AI based in Jerusalem, who says current LLMs are not able to formulate novel and useful scientific directions beyond basic superficial combination of buzzwords. Mm-hmm. Very negative view.
Absolutely.
And maybe I can also bring in one quote from someone who actually tried, one of these AI co-scientists, Thomas Montaigne from Stanford University, who says, it went further than a postdoc would on a first try of writing a grant, and it only took 2 minutes, and it's a hoot to use.
Oh, wow. 2 minutes. I mean, you're a postdoc in biology.
I used to be, yeah.
Yes.
Yes.
So quite a differentiated picture as we look at the topic, a co-scientist, an AI scientist. Maybe we approach the topic best when we look at science itself and the role of the scientist. How do scientists today, especially in the world of the biorevolution, work?
Yeah, I mean, in general, I think scientists still have the cognitive tools available that their forebears had. So before there were computers, before there was technology, or what we would consider modern electronic technology, there was already science. There was a scientific method. So scientists observe the world, then they often collect data, and then they draw some hypothesis. So how does the world work? And then they test this hypothesis by experimenting, by testing, does that actually make sense, what I found? And then they iterate upon the hypothesis, coming up with new hypotheses. So this is the way that science works, that scientists apply the so-called scientific method. And this is something that's still done today. That said, I think the world in which scientists operate has changed a lot, because back in the days, there was a lot less knowledge, there was a lot less data, and there was a lot less technology. So nowadays, a scientist has mountains of scientific evidence, of publications, of databases available, and it has become, for most research fields, completely impossible to read it all, to digest it all. So how do you then form your hypothesis based on the data? Another thing, and this is quite interesting, and this is something that the authors from the Google co-scientist also mention, is the so-called conundrum between breadth and depth. So you have on the one hand the deep knowledge about a specific topic, which requires years and years of study, of research, but on the other hand you have this need for interdisciplinarity. So you need to be broader in order to make the right connections. For example, we have the example of the CRISPR discovery, where we had people from different fields, including even people who worked on bacteria and yogurts, coming to conclusions, and also this main collaboration between biochemistry and microbiologists. So this is really something where you see like this interdisciplinarity, having multiple disciplines working towards the same goal, and maybe also having like fruitful knowledge that can help the others, is a really important part of finding new scientific hypotheses. That said, having both of it, having the deep knowledge, spending years and years on this one topic, and also having this breadth can be actually quite challenging. And this is what at least the Google team postulates, where the AI scientist can come in helpful.
One trap you might step into is, of course, that your findings are already out there somewhere. Because with the flood of papers that are publicized, that are published, you might find, okay, somebody else in South Korea had that idea as well.
Absolutely,
right?
absolutely.
And
so
this, right?
This is also part of it, of course, that you want to come up with novel ideas so that your ideas are not already being done. That said, I think in science there's a lot to be said for replicating results. So it's a good idea to do something twice or thrice. At the same time, again, also for the CRISPR story, which would classify as a story of multiple discoveries,
Absolutely.
maybe where multiple people come to the same conclusion. But at the same time, you, of course, want to have some kind of novelty. So your paper and also your grants have some aha value for the people who evaluate them.
Right. So this, at this stage, sounds a lot like you're making the case for, yes, of course, we need AI for the research. But maybe then we need the genius as well, and we might come to that point a little later. But we have to distinguish. Now we were talking about the scientist, and we need to talk about the AI scientist, be it the co-pilot or the independent scientist itself. What is behind the scene?
Yeah, so I think there are different approaches to what an AI scientist could constitute. So there are tools that are meant just for improving research in general. This is, for example, OpenAI's or Google's DeepResearch tools. They're not specifically for science, but they make it easier to scrub the internet of information, to write quite cohesive reports, to assign sources, extract quotes. And this works actually in the hands of myself and also of scientists who have tried it pretty well to an extent. I'll get to that in a second.
Postdoc level? To come back to our quote in the beginning?
Yeah. So I think OpenAI, they also describe their tool as a research analyst. And I've been working in consulting for a while. And I would agree that it's at the level of a junior research analyst. So someone who is very good at compiling the information, of having pretty complete information, of drawing some conclusions, and then needing supervision to get to the final so what moment of having compiled all this information. Because that's something that it doesn't do as well. And I think this is something that people are trying to address by having these so-called multi-agent systems. So agentic AI, it's a little bit of a fuzzy term. It's a little bit hard to say what it really means, but I think it means an AI model that's based on a large language model, on an LLM, that has more autonomy, so more own decision power than a classical LLM would have, and also having more interfaces with other tools. So, for example, databases, other AI tools, for example, for the field of biology. This could be, for example, AlphaFold, these kind of things. Interfacing with also just general systems that we have in our on our computers, and therefore having a little bit more complete output and also needing less supervision than a classical LLM would. I think they still need supervision, but let's see. And these multi-agent systems, this is really interesting. And I think there are two very prominent examples, one from Google and one from Stanford, from James Su's labs. And what they do is to have either for the Stanford version, that's the virtual lab, having different scientist personas. So they have a principal investigator, they have a critic who has gives feedback and is critical of what's being said. And then they can assign different specialties. So for example, a neuroscientist or a microbiologist or someone that we need in this team, which is actually pretty cool.
Seems to make a lot of sense, because you have to feed those entities, if you may call them, certain traits, certain knowledge bases, right?
Yeah, I think this is something that they're currently trying to also do, to feed them the specific knowledge base. I think at the current stage, it's more that they work independently and they take on the role of that. It's not that they, I know that they were working on this, but if they implemented it already, I don't know, that you have also the literature base that's now specific to the neuroscientist. And Google is taking a little bit different approach, so they don't assign specialties, but they assign different parts of the scientific process. So, for example, reasoning, critique, seeing if there is like duplicate information. So these kind of things. So it's a little bit different approach, but in general, what they do, and there are also other types of these multi-agent systems. For example, one from Shanghai University, where you have these agents that collaborate in a way that scientists would also collaborate. So they take on different roles, whatever they may be. They conduct lab meetings, so they have a discussion in private without the human present, and then they come back with some kind of hypothesis, with some kind of analysis. And the question is this actually better than just having ChatGPT do the work?
Right.
And it seems at least, so this is at a very early stage, but there is a recent Nature paper commentary where they had researchers try out these models and see how well they worked in their hands. This is also where I extracted some of these quotes that we had in the beginning from. And it was a little bit mixed response, but in general, I think people preferred the outputs of the multi-agentic AI, saying that they were scientifically more novel and more impactful. And also on some scientific tests, I think the virtual lab, they tried that the answers to different test questions were actually more scientifically sound than what a single large language model would produce. That said, I mean, one thing that we also have to take into account is that already the single large language model, like ChatGPT, often produces outputs that are considered better than what humans might create. There was a study, I mean, we know it from the field of medicine, where the ChatGPT, Gemini, and others beat human physicians who are not experts at diagnosing. This is a very narrow task. Research reports or coming up with research hypothesis, it's much broader, it's more complex, but still I think it tells you that at certain narrow levels, actually the AI already produces something that humans consider a better output. There was also a recent study that tested an AI scientist that wrote scientific summaries in the style of Wikipedia, and experts had to check if they preferred the LLM output or the Wikipedia article that was written by human scientists, and they preferred the AI.
Oh, wow. Yes.
Or the majority preferred the AI. So again, I mean, this shows that there is already some, let's say the AI is reaching in some of the disciplines a human level. The question is, can it really conduct the research autonomously? And I think this is the key question for these AI scientists. So how much autonomy can they even have?
Yeah. So, I mean, those are the ingredients you would wish to have from a human scientist, and probably you want to have exactly the same thing from the AI scientist: the accuracy, the autonomy, the novelty, the ingenuity. So all of this you need to have good science. And the question, of course, is, again, given all those experiments at Stanford and other places, how close are we right now?
Yeah, that's a good question.
Yeah.
So I think what we just discussed is along the lines of accuracy. So
absolutely.
Is it correct what the model produces? It's more correct than if you use a single LLM. That's also already true for example, the DeepResearch tool. So having more deeper reasoning, so reasoning in quotation marks, because probably it doesn't reason, but it's coming closer to simulating it. The models still hallucinate. So we talked about that in many of the previous episodes.
Yes.
It's a feature, not a bug. Well, it's a bug and a feature, but they just hallucinate. It's the way these models work. So they will not stop hallucinating just because there are multiple agents. But what the scientist observed, for example, in Zeus Lab, is that if you have a critic on board, so an agent who acts as a critic, you can weed out some of the hallucinations. Still, you will have them. And then there are some scientists who say that maybe this hallucination can also actually spark ingenuity, can spark out-of-the-box thinking, lead you down.
Amazing. Because we do exactly the same thing,
Exactly.
maybe?
Yeah,
Of
we
course.
also...
Yes, we do.
We do, and we also make mistakes, right? Or we draw the wrong conclusion. So
Right,
I think
right.
this, in terms of accuracy, is not maybe the biggest problem. The problem is, of course, that you probably need to be an expert in order to know if the model hallucinates. And this
Right.
is, of course, challenging, especially if we come to this aspect of interdisciplinarity, where you would prefer to have a sound opinion of an expert from another field. For example, if I would now want to talk about quantum biology, which I can really understand only very rudimentary. So if someone tells me, if ChatGPT, if my AI scientist collaborator tells me something about it, I have to take it at face value. And this, I think, is, of course, a little bit tricky. But I think there is another part, and I think this is more challenging, and this is that the model doesn't have world knowledge. So the model knows things, but it doesn't know where they come from. And I mean, this is something that also, for example, the chief scientist at OpenAI recognized in a recent interview, that, I mean, you lack the spatial and the temporal information of the knowledge. And this is a challenge because in science, we know we have a hypothesis from the 1980s, and now we have a new hypothesis that's 2 years ago. And most likely we prefer the hypothesis that's 2 years ago because it's probably the more recent and the more correct one. And these models sometimes don't take that into account and just have a...
You're saying they don't distinguish at all.
Well,
so
they
1980 is as good as 2025?
I think they are... they can distinguish the quality of information to a certain extent because they, I mean, will ingest the commentary on it. And if the commentary says this is not true anymore, then I think they're pretty good at picking that out. But they are not so good at contextualizing it. So they would, for example, in a summary, and this is something that I think also Derek Lowe, he's a very prominent AI skeptic and science blogger, whom I'm quoting here and there because he writes a very good column on the topic, noticed. So he tried DeepResearch for figuring out the toxicity mechanism of thalidomide. Thalidomide is what in Germany we know as Contergan, that had a big scandal of causing birth defects. Then it became a very high-selling, best-selling cancer drug. And it also sparked a completely new research field through the discovery of the mechanism. And he said, he was actually praising the model to a certain extent for a very complete and good report, but it lacked this final interpretation of, for example, what it meant to figure out the mechanism, and also put information next to, I don't know if that's from Lowe's blog or from another one that I read, but it just puts information in a summary without contextualizing that one hypothesis has already superseded the other. And this is, of course, a challenge. At the same time, I have to say, again, like for the hallucinations, potentially sparking ingenuity in scientists, I think also having older hypotheses revisited, because, I mean, in science, we also have a little bit of groupthink, that everyone is very excited about something and then everyone follows along, and having this more out of the box thinking where you think maybe we still look at the weird pieces of data that can still be relevant, I think. So the problem is that I think because the models are not completely there yet to contextualize the information, and I think that is probably also true for the multi-agentic AI systems, even though they're better at it, the human has the job to contextualize it. And we're at the level of a junior research analyst, probably at the level of a PhD student in some respects, but we're not at the level of the professor.
Yeah, but which is in itself fantastic and amazing, of course.
It is.
How far we've traveled in a short amount of time, we must say. So what remains to be discussed is a kind of an outlook. Number one, scientists are not going, as I understand you, not going out of business. So you're not going to be unemployed anytime soon, right?
No, I mean, I'm also not actively doing science anymore. So I'm more I'm actually more likely to be replaced by by an AI than a scientist who works in a
I don't
lab
think
is,
so.
because this is part of this question of autonomy. The thing is that, I mean, the model can do things by itself, but only in its computer environment, right? So it cannot start suddenly going out in the world and making observations. There are examples. There's the AI scientist from a Tokyo-based startup that collaborated with a university in the UK and in Canada, and they created in the field of machine learning an AI scientist who by itself wrote a complete paper and also conducted research by iterating on the literature, augmenting the literature, but this didn't need any human supervision anymore. So this really created the paper, and they even had like a reviewer who reviewed it then, and they submitted it to a machine learning conference, and the paper was accepted. So at the conference, they knew that there would be probably 1 to 3 AI-generated abstracts, and this was accepted to this conference. That said, I mean, this is only possible in completely theoretical sciences. This is not a possibility for biology, where the wet lab is still relevant, even though we are now making more. I mean, predictions have become much more relevant. I mean, we see it with AlphaFold, we see it with many other tools, but at the same time, we still have to test certain hypotheses in a lab context. So this is
real world, yes,
in a real world context. So I think one of the things that, as an outlook to the future, might happen is that these AI scientists are actually hooked up to automated labs. That we see that, for example, there's companies like, for example, Recursion who do it, like Zara who do it, who also Genentech, where they have these cycles of having generating hypotheses, testing them in an automated lab, and then putting them back into the AI, having these training cycles where new data feeds the AI. But that is mostly in the context of a pretty, I would not say narrow hypothesis, but this is not the same type of hypothesis generation that we're currently seeing with these AI scientists. So expanding on that and having more advanced automated labs hooked up to these pretty autonomous AI agents could, of course, save a lot of time. And save a lot of money. I mean, for this machine learning paper, they said producing the whole paper cost $15. So this is, and a human researcher would have taken a year or something to produce it. So that is a great benefit of it. But I think there's also, of course, the risk of creating meaningless research, of creating low quality research. We see that, I mean, since the advent of ChatGPT, there are multiple studies who warn of like a flood of low quality papers that have been generated based on database research, that are just not drawing the right conclusions or are just not adding anything. And again, if we think about this flood of research that we have to digest, this is a problem. And this is a problem that we also see for generally the internet, social media, any kind of articles. You can immediately spot AI has been involved in this, kind of doesn't make sense. The conclusion is not quite sound. So what do we do with it? And I think in science, we're really dependent not only on the breadth and on the like broader informations about research, but also on the specialists who really dig down and spend 30 years researching this one thing to teach us how the world works. And I think this is something that the AI currently cannot do as well. And I think
just a small take on, because we've been talking about this in more than one episode, the quality of data determines if this flies or falls, I think, as well. Because the systematic approach, how do you grant access to data sets worldwide over, I mean, there's still a number of ivory towers around who shield their data kind of, worldwide. And especially in the field of pharma, I think, and biology and the BioRevolution altogether. So there's room to evolve in this part, I think, as well. And to get rid even more of hallucination, one path to take is to determine more of the experts that you mentioned, of course. But on the other hand side, the general overall quality of data, isn't it?
Yeah, I would say so. Yes. So I think these AI scientists, they are partly literature based. So they really scurry the scientific literature, but also the internet. But you can also upload your own experimental data.
Okay.
So it's a mixture of both. And you can also point it towards relevant data sources.
All right.
So in that sense, I think here we're not so limited by the publicly available data, because you could potentially also use your own experimental data. That said, I think many companies, like for example also the companies that I just mentioned who are working on these automated labs, they have recognized that it's important to create high quality data to train AI models. So it's like really a virtuous cycle of creating good data and then having good model outputs rather than having this noisy, messy data. But this is not data that in most cases will be made publicly available. This is then the treasure trove of these specific companies who have the data. Yeah.
So what's the one thing that you expect in, say, 5 years? What is the one thing you put your eyes on and you say, wow, this is the one thing that is evolving right now and I can't wait until it becomes truth?
I think I am not entirely sure if I'm betting on the agentic AI. I think there are predictions going in different directions, and I am not 100% sold and that this concept works well enough to circumvent the challenges that the large language models have, like for example hallucinations and others. But I think the concept of having a virtual lab and having a virtual lab of experts from different fields. And I have to say this goes beyond, I think, studies in the biosciences. This could also in the humanities, for example, be quite interesting to have multiple disciplines. So I don't know if this will become reality, but what I would love to see is what we discussed in the beginning, having AI scientists who are trained in specific disciplines who you can use even as a non-expert or as an expert in a specific research field to enrich your hypothesis. I think one thing that I would also see as interesting and relevant, again, for science and also for medicine, is to somehow program AI scientists or AI agents who are a little bit argumentative, who have more taste for discourse. Because one of, which is, I think, very difficult because, I mean, these are models, not humans, right?
Of course,
we humanize them a lot, but they are not. They are stochastic models that predict the next word in the sentence.
Right.
But the problem is that their programming is to be a people pleaser. So if they come up with the right hypothesis and I say, no, but this is wrong, they will say, oh, I'm sorry, yeah, this is wrong, and produce another answer that's not correct. And this is not good. And at the same time...
So they don't argue.
They don't argue, and they're not good at discourse. So I think this was also a commentary, for example, on the AI scientists that were tested, that they are, I mean, they don't speak like scientists. They speak in lists. They speak ChatGPT-ish. And this is, of course, and I mean, this is something that we also notice if you communicate with someone, that people speak ChatGPT-ish, which is like a summary header with a number of bullets. If you see that somewhere, you're like, okay, nice.
Yeah, it's not you.
It's not you. But I think for science and for medicine, and this is also a discussion that could be had around this AI-based diagnosis and people perceiving chatbots as more empathetic than human doctors. They are people pleasers. These models will tell you what you want to hear because this is the way they are programmed. But in certain contexts, it's actually a good idea to push back. And this would be for a scientist who's on stage giving a talk and having the researcher who's the key competitor asking a difficult question. I mean, this will set your brain on fire and make you produce a good answer. At the same time, for example, a doctor who would never push back on a patient telling them something or saying like the doctor says, stop smoking. And the patient said, no, I don't want to. And then the doctor says, oh, I'm sorry. You shouldn't stop smoking, of course.
This would be ChatGPT-ish.
Yeah, exactly. So I mean, there are contexts where this programming doesn't make sense. And
course,
I saw something interesting recently, which was about training like pharma representatives, but this was including different personas. So you also could program into your AI agent the difficulty of the conversation. So having someone who really challenges you.
Yeah.
And I think this could be really interesting in the context of these virtual labs also, to have someone who is more argumentative in the mix.
Out of the lab into the code, an age of AI scientists. I must admit, I like the phrasing of the co-pilots or the co-scientists a lot more than the autonomous, because at the end of this program, I think in the near future, I don't really believe in it, but that's maybe my deficit or my lack of intuition here. Thank you very much, Izzy.
Thank you.
This was our BioRevolution podcast. Many thanks for listening and this time watching as well. If you want further information, you'll find those at
science-tales.com.
See you soon. Bye-bye.